Okay, we back. This is where we left off, I think. This is a dirty kitchen. That's one big casting of concrete, one solid chunk, heavily reinforced. I don't know how much rebar's in there, but we cleaned up what we had laying around. Okay, what we're going on to today is putting down rebar for our ground mount solar array. This is somewhere behind the house. No, that's on the roof. I don't know why they're up there. Anyway, over in the far corner over here, you can see down on the ground where the columns are started. I think what they're doing is inventorying how many bars they have bent of all the different sizes. Because we redesigned this building from like a rectangle with a small power room on the back, also a rectangle, into one large rectangle. It's just how the digging was going, and it was less dirt to move. This land back here in the back, you can see it looks almost flat, but it's actually terraced rice paddies. There's about an 18-inch drop every 75 feet or so. It goes back 900 feet. This is also from the roof. Looking down, you see the cistern in the lower right-hand corner and the septic tank over here, if that helps anybody locate where they're at. Also, you see blue down there, and a bunch of bags staged ready to pour. These we use the 6 mil. They call it black, but it's really dark green polyethylene in the States. It's illegal to import that in the Philippines. We did not know that, and we sent 2 rolls over, and they're underneath of this house. Outside, out of mind. But they're completely buried under concrete. They're not coming back. And it's all waterproof down there, so it can't do anything. Here's a closer look up at what we're using in place of the polyethylene. This they call tarpaulin or tarpaulin, or tarpaulin, whichever your local hardware store calls it. But it's the stuff they make banners of for advertising that they hang on buildings and things. It's like, I thought it was 12-foot wide strips, but it looks like it's a lot bigger than that. It looks like it's more like 15 on this group. Now you see here these deeper trenches going around here. And that's for the footer. We're doing a monolithic pour of the footer and the slab. That lets us use a thinner slab. It's only 5 inches thick this time instead of 7 or 8. Like the cistern, the floor, that's 9 inches, and the septic tank is 8, and the house is 7. But this is going to be a 6-inch footer and a 5-inch floor. The house has got tie beams under the floor, but the floor is poured over top of them. They're not a monolithic pour. The tie beams are 24 wide, 18 inches deep in the house. This is 6 inches deep and 24 wide. It just goes under where the walls are. Now you see these like teepees over here down the back side. If you take 3 bars in a row and just cross them over and put 1 tie wire on them, that gets them standing upright to get started. And you can't make it out in this picture, but you will in other ones. There's a board back here. It's a 2x3 cocoa lumber with notches cut in it. I was going to use the 7 3/4 inch notches, but I think the ones that was down there behind the house were 8 3/4 from the shrimp tank. And they were, fairly good condition. So we decided we'd just use them because they're still overkill for the floor at that spacing. A 5-inch floor, how much do you really need? And it's completely supported by very hard dirt. This is looking from farther back, and you see there's no bars in the near part of the picture. But you can see the rebar sticking up from the pads. Those pads are poured flush with the dirt. There's a 3-inch 2-foot by 2-foot in the bottom of the holes that makes all the holes the same height and level. And then these column things, rebars are set on it. And then it's poured as a block of cement from there up to ground level. and they're like 2 feet deep and 2 feet by 2 feet. 15 inches deep. These are 15-inch blocks on a 3-inch block. And you can see that this is where the partition wall goes between the, this side is fish food storage, a shop where we can make dirty stuff. And then the other end of it is the powerhouse for the solar array. You also see sitting out here the what we call our biscuits. They manufacture these. We don't buy rebar trees. We make them out of concrete. They don't rust and they're termite proof. There's a closer view of bars sitting in the notch boards. The notch boards, you can overlap them any length you want. Now, they can take these out. They'll put 2 of these concrete biscuits beside, a couple down there. They flop them over on the side where they're flat. They're only 1 3/4 inches thick. They can just drag them right off the end. You wouldn't think you could get these out when you have these side perimeter boards. But what they do is they spin them around until they're parallel to that. So when they go out past this, they got the space between the rebar and the batter board there, and lift them straight up. But they did that the entire house with notch boards, every piece of it. And the beams, they were done with these notch boards laying on sawhorses to locate the stirrups. So they're spaced, by an engineering calculation rather than that looks good to me. It looks like that looks good to me, but it's not. It's fairly precise. Nothing to do there. Okay, they've got one from each side and meeting somewheres out here. And then there's putting a bar across that connects them together. There'd be a 16-inch overlap. I think it's supposed to be 27 bar diameters by code. But what we did, we figured out what we needed for a 16 millimeter bar, because we didn't use 18s except on the these vertical columns on the house, maybe 18 on the uprights on the first level. I kind of think they were, but 16 is plenty, because there's 24 vertical bars in each one of those 20 columns. That's a bunch of rebar, especially when all this wall and this beam are all poured together. They're just like another very tall beam. They got a 24 by 18 beam on the bottom and a 14 by 24 high on the top. And they're keyed into the center of these columns with a bunch of rebars. We got off track. Let me go someplace else here. Oh, here's one thing. Okay, what we're looking at here is our north, the tall side of the array, and the south, the short side of the array. That's the angle, 14 1/4 degrees. You can call these by measuring the 2 legs of the part when you bend it. But what we do is we call them colors. If we're really on top of our game that week, we'll use a tint color that matches the color name. We would throw some dark blue paint in the white paint, and this would turn out sort of a pale blue, and they would be from then on known as blue bars. Same thing, these black bars. Still black and white to get gray, but we call them black bars even though the paint would be gray. And then we have red bars. These are the connectors. And if you measure this overlap here, that's 16 inches. Since it's 27 bar diameters, when you get down to a number 12 bar, which is what these are, it's way more than 27 bar diameters. And if you're using number 10 bars, it's even more. But having one number for them to use through the whole build, nobody has to ask. They know what it's going to be. And they know, but we can walk around and we can see any that aren't. It's really obvious after you've done this for a while. And you go over there and you put your foot on it and point and give them that question mark sign. And they come over and get a tape out. And then it's a flurry of all hands on deck pulling them bars out and getting them right. It doesn't take them long to straighten it up. What I'm showing is this is, we'll probably hear her on the computer there. She's talking to the foreman on Messenger. She keeps wanting to know where these bars go. I keep saying you tire the entire flat grid. use up all the bars that we made for the original bar plan. And these will be repurposed also by cutting some that were U-shaped in half to make L's. But I can't tell you exactly how many there are. From my drawing is set for 7 3/4 inch spacing. But I think the notch boards that we're using for this are 8 3/4 inch spacing. So it will be 1 or 2 less on a long run than this. But they're getting tangled up in trying to know where everything goes rather than just do it in order. See, if you put your north-south bars here, and basically put this all down, they'd be tied in groups of 3 down both sides, so they stay in the notch boards without flopping out, and so they stay pretty much upright. And once you have these north-south, then you have east-west bars. This is where the confusion started. These red bars, because we were doing counts of so many for this and so many for that, we called them 2 different things. We called them reds and we called them blacks. Just because we wanted to count each group and put them all in a pile. So when we put them up, we could just take that entire pile and they grab 4 or 5 at a time, one guy in each end, and they hustle them from out of the house down to wherever you're going. It doesn't take long to move them. But if you were getting them out of 2 different piles, and confused, no telling what you end up with. Now the problem is that they're putting these blues are the same as the blues here. Same blue. Unfortunately, they're used long way here, and they are used long way up, short way at the bottom on this thing here. And so what I'm trying to get them to do is the 3 blocks to go on this side. We decided rather than having to hire an extra 7 guys and only work them like 2 days and then maybe not get them another day that same week. It might be like Monday to the next Monday. It's kind of hard to get a guy to work 1 day. If he's desperate for money, that's all right. But this is the heaviest work we do is pouring concrete. And I think it's just abusive. So we're going to take what do we have? 3, 4, 5, 6 people that work year-round, 6 days a week. They don't have a problem pouring these couple of bags. I could tell you what they are if I wanted to. Do I want to? Sure I do. This is what we turned it into, is if I get my way, or my brothers, I remember I'm not running this job. I just do the drawing. This is my wife's job. She's in charge. She's Filipino. It makes sense that she's in charge because they're better with money than Americans are. And speaking the language is definitely an advantage. So we have, well, down here you see, you can't really read that. Okay, 38 bags written on that block of concrete. That's for the footer and the slab for that 1 block. The next one over here says 34 bags. And if we look around, this is 32 bags for the food storage. Our little shop over here is 31 bags. So we know how many bags of concrete it takes. And that's done by using CAD. It's up here in the top. There's a cursor didn't show. Oh, it's off screen. It says analyze across the top toolbar. And it's analyze, mass properties, volume. Our drawing units in the drawing are inches. I can also multiply an entire drawing by 2.54 and turn them into metric. And all the dimensions change to the metric number. But inches are close enough for a concrete slab. If they get them within a half an inch, nobody would ever know the difference. Though we have used millimeters a lot. They don't care anymore. At first they didn't understand inches. But after we got the Benji Boy Ironworks on site, and they were using inches, and they were using both. And so I changed over to metric. Oh, this written on these things is also things like first pour, second pour, third pour. This is an intermediate stage. We've since changed the order we're pouring them in. Actually, we've changed them. This is the final stage. First pour is the end where the bags are stacked right here. Though what she's going to do, is my understanding, she's going to pour these 3 blocks over here. That gives us someplace that's flat, hard concrete out of the mud, and to stack all her bags of stuff and work the mixer and things like that. And then it's a short carry over to here. They may put down some phenolic board, take the mixer out here and just turn the mixer up and dump it out. And then, after they do about 2 loads this way and 2 loads that way, they'll move the mixer like 6 or 7 feet and do it again, instead of carrying all the concrete in buckets. This is a fairly small pour. It's 240. That's 20 feet. 20 times 12, 240. And 28, 19 feet. 19 feet and a little over 3/8. A couple 20 thousandths over 3/8. In my machine shop, 20 thousandths is a lot. There's not much here. Okay, let's go back to where we were here. But that's this is an example of how the drawings that we would send look. When we get to doing the slip forms, these outside dimensions are the length of the individual slip form. We have 95.9. That's the same thing as a 96. It's just the accuracy of the CAD system and how, whether I zoomed in or not, trying to pick the points for the dimension. Just laziness on my part. But these also show you how the corner pieces go. No, it's gone to auto save. You really can't make it out. There's different ways the corners, inside and outside corners, go together. And these 51 and a little over 3/4 and 44 and almost 1/4. So it's a 51 on this side and a 53 on the back. That's because the sheet of plywood was cut to make this outside and this inside. And the other one is this outside and that inside. And that gives us 3 square straight edges of phenolic board that can't delaminate. And the extra, the cut end, all goes outside of where the concrete would be, and it's got a 2x3 screwed to it. And these 2x3s are good wood. In our case, that's Nara. I don't like the fact that we consume Nara and acacia, things like that, for forms. But in my defense, the same boards we bought in 2014 when we arrived in the Philippines, we are still using them today. And we'll run them through the planer and edge joint them into tabletops and furnish them when we're done. And all these 3/4 inch and 9/16 holes, we'll just fill them with plugs. You take a hole saw and you make a plug, put some glue in it, and knock it in there. And it just adds character to what you're doing. My opinion is it adds character. Anyway, the really messy part is when they get to this. All these different colors, those are all bars that were cut to make the blue bent ones that were corner pieces. These red ones were also corner pieces. For the vertical walls, these are just 20-foot bars. This whole thing across here is 20-foot bars. These were cut to be something, but I don't remember what it was. And same thing with these light green ones. They were cut to be something. But this was drawn up to consume the bars we cut before we had trouble digging the dirt, and it was taking weeks. These guys are really good at the concrete work and adequate at digging dirt. Better than mediocre. I'll call them adequate. Okay. But when it comes to the technical work and getting the concrete the right water content, and pre-staging all these bags close to where they're working, and the ingenuity running the mixer, and all that kind of stuff. And look how neat they tie all these rebars. You see these, I don't know if you can see it here or make it out. This doesn't, I was going to zoom like it was something else. I don't think I can zoom that. But what I was going to say is these ends are bent 135, not 90. They go back 4 inches into towards the center of the column. That makes a hook. That's called anchorage on rebar talk. They're close together down here on the parts you can't see. And up here, there's going to be a ring of flat bar on edge with, what do you call it? Threaded rod coupling nuts. And the coupling nut will have a piece of threaded rod stuck up to go out in the top. Piece of plastic pipe as a shield. A flat washer on both ends. A nut on the side of this flat washer that's just above the concrete. The washer will be flush with the concrete. And then the thread sticking up. When you screw the threaded rod, you screw it to the bottom of the coupling nut. And you can either just put a piece of adhesive tape or a little wipe of silicone, what do you call it? Not caulking. The kind of stuff you put on gaskets, the silicone gasket, red RTV. Something like that is extremely weather, heat, water, whatever resistant. And that way, if you should break off one of these rods, or if you used mild steel and the threads got bad, you can unscrew it because it's in a plastic sleeve and in a coupling nut. I did this with heavy machinery. I did not invent this idea. I just copied it. We used 2-inch steel pipe with 1-inch threaded rods, high tensile rods, threaded with a pipe threader in the lathe. So we had like 3 inches of threads on the top and 2 inches of threads in the bottom. And the threads go right to the first nut thread. They go jammed into it. Pretty tight. It's a standard fit at the bottom, and it's a little tighter fit at the top. I don't know why they had to be tighter, but that's what the people want that designed some of the machinery I was putting in. Just to make it hard, I think. Let's end this video and start again because it's got long.